So good day, everyone, and welcome to another session with the Women in Data Science Trinidad and Tobago team. I am the current ambassador, and in today's session, we have an exciting spotlight talk on AI applications in agriculture in the Caribbean with our feature speaker, Miss Fazeeia Mohammed. Thank you very much for joining us today. And we look forward to giving you a really fruitful and meaningful session. So before we begin, for those of you who may or may not know about the team that we are part of, it's really the Women in Data Science global organization, which really elevates women globally through the celebration, inspiration, education, and support of these activities worldwide, which include conferences, our recently concluded Datathon challenge, where various teams globally participated in a really exciting climate challenge, podcasts, WiDS Next Generation for outreach in secondary schools, and also a number of workshops. And before we jump into today's session, I know this is the month of March, and on March the 8th, we celebrate International Women's Day. So our team would just like to extend a celebratory message, really giving the forefront to women who have achieved, and women and girls who have achieved so much worldwide, and really give the context of raising awareness about achieving that gender equality in all fields for both women and underrepresented groups. So I would just like to play for you a short video which will actually give some context. You can let me know if you're hearing the video when it starts, some of the messages from the ambassadors. So let me know in the chat if the video is audible.
Hello, my name is Flora Huang, and I'm from Philadelphia, USA.
Hello, we are Women in Data Science.
I became a WiDS ambassador because I dream of an equitable world where empowered women help humanity make better decisions through data science.
As a woman, I'm hoping more Peruvian women would be motivated to join this exciting field.
The WiDS community has really enhanced my sense of purpose in these life goals, and it has really built my confidence in such a meaningful way to be able to mentor, motivate, and support others.
The most rewarding and impactful aspect about my work as a clinical data scientist is to use the data generated by doctors, nurses, and the healthcare system to improve the care of future patients.
I'm delighted to bring this event to Pakistan, along with so many WiDS ambassadors worldwide, so that we can inspire all young girls or women to take up career in data science.
The use of data science to address climate change and sustainability issues continues to inspire me in my data science journey.
Through WiDS Alexandria, I've got the chance to meet with brilliant female professors, learn about the research, and bring that to my community as well.
I'm a WiDS ambassador because I wanted to inspire more young girls like me to join the field of data science, and I believe that in the future there must be more women in this field.
I'm really excited to continue bringing WiDS events to my school and schools across Australia to empower girls to get involved in the field.
It's great that we've got Women in Data Science events, and know that there's so many more inspiring stories as part of the Women in Data Science journey.
Hi, I'm Carolyn Bertozzi, and I am a chemist who works in the area of drug discovery. I've had many opportunities in my life to collaborate with data scientists. They've been absolutely central to the work that we do. We couldn't have made the discoveries that we've made without having people to analyze very large data sets and to help us find hidden trends within them. Now, when I was growing up, I was somewhat insulated from the idea that women or girls couldn't be scientists because I came from a family of scientists. And when I was in college, I learned that not everyone had that privilege. I hope that all of you women data scientists or aspiring data scientists will truly feel that you belong in the field, because I believe it, and your participation is absolutely essential for us to bring the full benefits of data science to solve the big problems in humanity. So just as I was so fortunate to have a family that created an environment where I could believe in myself as a scientist, I'm hoping that you all have the confidence to pursue your dreams and that you help the generation that follows you in the same way that hopefully someone of my generation can be of help to you. Good luck with all of your work.
Great. So I hope you all enjoyed that video, just to give us some more inspiration to actually propel ourselves in the field, whether it be an actual data scientist, industry-related job, or data science-related fields, wherever you are in that realm. And as far as it goes, we were really happy to have hosted our Datathon workshops from January to February. And of course, we have these regional events in March. So today's event with our feature speaker is our Spotlight Talk. So she'll give you some context as to the actual theme that we are talking about today in terms of AI and agriculture. And next Saturday, which is the 11th of March, we will also host a fireside chat, which is a really nice informal panel discussion with some really amazing women in the field, including our feature speaker today, Mindy Mohammed. And we will actually have a really nice short networking session afterwards. So you can actually feel free to go on our website and sign up for that event. So pressing on, today's talk, as we know, as I mentioned before, it's given us some context to applications of AI in agriculture within the Caribbean. And our feature speaker is Fazeeia Mindy Mohammed. She's a data analyst at Digicel, and she's also a data scientist at TTLAB in Trinidad and Tobago. So at this point, before she begins her very informative and interesting talk, I'm really excited for you all to hear what she has to say. I would like to invite her to come in and give us some context about her background. Mindy, she likes to be called Mindy. So Mindy, you want to just jump in and give us a little bit about yourself and your background?
Hi, morning, everyone. Yeah, Mindy is fine. So I started off my educational journey with BSc in Environmental and Natural Resource Management and Biology. So my love for biology and the application of, any kind of computer science or emerging technology in the field of, environmental and biology was there from the beginning. And then I realized that I was limited by my own knowledge. So I went and did another degree in computer science, a specialized degree in it, so that I can go and do everything from the start to the end by myself. And I currently work at the Digicel group. What I do there is I apply machine learning to different data sets to derive insights for the company. I also work with TTLAB under Professor Patrick Hussein. He's a really great mentor. And what I do there is I look for different problems in the space of environmental and biology and machine learning. And I'm able to freely do any kind of research I want, take it how far I want, and whatever support I need, he usually provides, which is really great. And it has really helped me grow as a person and as a scientist and a computer scientist in this field a lot. So yeah.
Excellent. So we're glad to hear that, and you have such a multi-dimensional background, so that's great. And for anybody who wants to get into the field, you realize you could start anywhere and jump in at any point in time. So Wendy, that's really inspirational. So at this point in time, I'm going to stop sharing and I will turn over to Mindy so that she can give you some context of her talk today. And Mindy, take the floor.
Hi. Yeah, so today I'll be talking about the FAIR project. So as part of TTLABs, I was fortunate to be the technical lead liaison for the FAIR project, which is a project that involved both the Cropper Foundation and TTLABs. And I was able to be a bridge between these two entities in order to create some insights into small farming practices in the Caribbean. So today I'd like to touch on the processes and challenges of creating these applications. As you may or may not know, climate change has had significant impact on small farming practices in the Caribbean. And the FAIR project really aimed to address these issues through the use of AI technology and UAV systems, and trying to mesh the bridge between local farming and industrial farming. The ultimate goal of the FAIR project is to demonstrate, it was really a pilot project, so it was really to demonstrate how modern farming can be applied and enhance productivity and efficiency in small-scale farming. The project involves several key factors, such as creating a dialogue between farmers and research experts, adapting current technologies to small farming practices, and evaluating the impact that AI can have within this industry through opportunity seeking. So we will explore the ways AI can help and the most pressing issues faced by small farmers in the Caribbean, from weather forecasting to crop management to yield optimization. We hope that I hope at the end of this project that you will have a better understanding of the FAIR project and what we aim to do and what we hope to do in the future, and we can get into it. So if you're in the space of precision agriculture, or if you're not, you would know that it has really revolutionized the way the industry moves forward. It enables people to make informed decisions about their fields based on data. And in recent years, the advancements in technology have made it possible to detect weeds more accurately, help farmers to optimize crop yields even further, and reduce the amount of chemicals that are being used by farmers. A study done recently by Hassan et al. Focused on weed detection in agricultural fields using a low-cost UAV system, which is always preferable in the Caribbean, anything low-cost that is efficient, to detect high-density vegetation spots that could indicate weed patches at various flight heights. However, our team had to use a little different approach because we aim to produce highly accurate results for every individual weed plant. So we try to implement pixel classification approaches. In summary, technology continues to play a significant part in improving farming practices. And with our innovative approach, we really hope to address weed issues more precisely to reduce chemical runoff. In addition to that, we also part of the project was aimed at irrigation scheduling, which is crucial for crop yield. And we live in a climate that experiences extreme heat and then extreme rain. So the management of soil moisture and other meteorological variables are now being used to monitor water stress and estimate the water loss from plant soil systems. However, these methods, how they currently are used, are very labor intensive, a little bit destructive, and unsuitable for automation. So our UAV approach was an approach that we chose because we wanted to make it easier for farmers. Using these technologies, we hope to be able to optimize irrigation scheduling and leverage more advanced techniques to have custom solutions. Our goal for the whole project was to provide farmers with insights on their crops and enable them to optimize irrigation schedules, and overall help them to learn more and know more about how technology can play a part in their everyday lives. We used some soil moisture sensors in addition to the UAV, and we made custom software for them after training our models to identify different patterns within water stress and all of the issues that we highlighted. And so you'll see the final product at the end of it. And it was a pilot project, so we hope that, if this is something that they are interested in, now they have all the tools, they have the know-how, and a front end so that they can implement it themselves, or with the aid of the Cropper Foundation and TTLABs, they can use it themselves. So let's get into what I'll be touching on today. One of the key problems that we identified in the Caribbean is a lack of data science and analytic tools, along with a lack of data. So we tried to address this issue on multiple levels using different types of data labeling techniques. We were able to collect data using advanced materials such as sensors, drones, and satellite imagery, but the end product really should just be able to take a picture and do analytics on it, any kind of image. The collection of data was then processed using sophisticated algorithms and filters that enabled us to extract valuable insights. We used this data to develop the models that allowed us to make these predictions and inform decisions. Throughout this project, we encountered several challenges that were unique to the Caribbean, and specifically the place that we chose to have our farm, our experimental farm. Some of these issues are like data quality issues, data integration problems, model complexity. However, we were able to overcome some of these challenges by collaborating with experts and incorporating feedback from the farmer themselves. So to demonstrate the interactivity with AI, we created a pilot application that showcased how agriculture and AI can interact. The application allowed farmers to access real-time data on weather and soil moisture, as well as show them insights into their own plot. It is important to note that this project was funded by National Geographic through the Earth for AI Innovation Grant Partnership. We also received equipment from NVIDIA. Our data scientists and software engineers came from TTLABs, where we worked under Professor Patrick Hussein, who is the National Geographic Explorer, our mentor and leader, and the Cropper Foundation, which is led by Omar, who is an innovator in the space of applying emerging technologies to environmental issues. He touches on ecotourism, and I just happened to be in the right place at the right time with the ideal knowledge background and, well, the passion for doing the work. As you may or may not know, some of the biggest challenges faced by small farmers in tropical islands is the lack of resources and tools to manage their crops effectively. So we address this by showing them a different way of doing that. So one of the key techniques that we implemented was the use of a drone. In large scale industries, drones are used to survey large areas of land quickly to detect pests, weed coverage, harvest times, nutrient deficiencies, and crop loss. We believe that some of these techniques can be applied to small farming situations by providing insights that can lead to increased crop yield in the face of climate change. To facilitate data collection, we purchased a NDVI, a DJI outfitted with an NDVI sensor. It's a DJI drone, and I do believe we got this sensor through Centera. This sensor assigns a value based on how much chlorophyll activity that you have. And by flying over the drone over the crops, we were able to collect data on healthy plants and identify areas that were struggling, which can give you information on irrigation, fertilization, and other critical factors. And the plants that we chose to do this for were peppers and pak choy because of the life cycle of these crops, and we'd be able to repeat the experiment a couple of times. However, the application of the NDVI sensor in small farming situations wasn't optimized because of the wide angle lens that the sensor has, which does not turn on under 50 meters elevation. And for this project, we were really unable to utilize the NDVI readings because it gave a general NDVI reading for for area, whereas we were looking at giving insight into specific plants, because what happens with small farmers is you would have like a small area that would be affected by something, whether it is pest or water stress, and it's not a large area that you're dealing with. They're small farmers, so we weren't able to fully utilize the NDVI readings. Additionally, we used a water sensor and MATLAB for image labeling. The data was collected using an RGB camera, and it was stored using cloud services that were provided through Azure, who partnered with National Geographic. Data processing was done on the videos collected from both the drone and the RGB camera. The videos were sliced up into frames, and the frames were then selected on the basis of clarity, overlap, and minimal artifacts in the image. So, and then the data was handed over to various data labeling teams. These data labeling teams were mostly sourced from the data science team from TTLAB and undergraduate students at the University of the West Indies. So we are going to jump a little bit into model development here. All right. So subsequent to labeling our data, we were ready to feed. We cleaned our data and we were ready to feed it into the machine learning models. We were addressing these specific problems: water stress in plants, detecting weeds and crops within an area of pepper. Determining weed density also within an area of pepper. We also wanted to detect damage to crops. Sometimes occasionally flooding happens and overwatering happens, and we wanted to be able to just fly a drone and see how much plants were affected by or were damaged by whatever natural disaster happened. And then we wanted to be able to determine the development stages. Well, we used the pak choy data set for this, and this is to promote optimal watering and fertilizing techniques. We created models that use supervised learning and implemented our models on binary and multi-class data. The binary data had only 2 labels: crop or weed, damaged or not damaged, stressed or not stressed. And the multi-classification data was used to determine weed densities in certain areas. And for developmental stages, it utilized labels like seedlings, 2 to 3 weeks of maturity and ready to harvest. Overall, this ascribes to the versatility of using both computer vision and machine learning. And we use these labels to, we use 3 different types of labeling. we used object detection, we used image classification, and semantic segmentation. These are results from the models that we created. These are just some of the models that we created. Because we knew we were building a app at the end of it, we really had to look at a varied set of models to get the best performance and also have to decrease processing times when a person takes an image and then uploads it into our software to then get a response after. It's really important to note that model training was a very resource-intensive task because we had 4K images, and neural networks usually require thousands of these images. We used image augmentation techniques on that also to make the small data sets more robust and accurate with its specific predictions. We applied the data to numerous models to compare and contrast mobile performance and latency between input and prediction. We used filters so that we were able to improve the performance of XGBoost models. And the XGBoost model was used in the web application. However, for the mobile application, we had to use more mobile net models because it was a particular size that was easy to integrate, and it gave a response in a favorable time. Each model performed differently based on the constraints of the data available, the image quality, and the overlap between images and the size of the data set that we were able to collect. In terms of performance, the models that utilize pixel label data performed at about 70% accuracy using the XGBoost model. Similarly, WiDS detection on pixel label data was about 70 to 80%, also using the XGBoost. It's really important to know that we were able to use different filters on the pre-processing part of these images. So it really made a difference in the overall performance. Then we also had our multi-classification models, for which we use a CNN to determine different developmental stages of pak choi or bok choy. It is a family of the bok choy. And we were able to get really nice accuracy for this. And we had at least 600 plus images in this data set, which is in contrast to these data sets, which only had about 200 images. So data is a major constraint in this situation. And then lastly, we did some object detection where we were able to have a labeled data set. This data set, we got information from farmers where they identified plants that they could not sell because of some sort of damage to it, and this didn't have as a great performance overall, but we are still tweaking the models to increase accuracy for this. So some challenges that we had to consider. Procuring the drone took a significant amount of time because the project started during COVID and there were many restrictions and lockdowns at that time. Additionally, certain drones required mandatory training to fly in Trinidad and Tobago. The drone purchase required the use of a broker to clear through customs, which was a time-consuming task. So it really ended up limiting the amount of data that we could collect within the time of the project. Additionally, for every drone flight, we had to get pre-approval, and post and pre-flight evaluations were also time-consuming. Additionally, and this was like a major issue, is that the use of the drone could really only be done in places that had good GPS signal, very minimal cloud cover, and minimal rainfall. And excessive green vegetation and high ppm of metals in the soil affected the drone's connectivity to the controller. So occasionally we would be flying the drone and the drone would behave erratically. Data labeling also was a very time-consuming task for this project, since we used numerous different types of data labeling techniques, and we implemented, while some of the data labeling techniques were easier to implement than others, it also involved training persons to understand the raw data displayed to them. So here we have a video, a demonstration of the web application. All right. This web application was done by Vishan Chatigan and his sister, Jade Chatigan. Can you all hear the sound on the video? I can't see the chat.
I don't think you could hear what happened. You could probably reshare and make sure it has share optimized for sound in the the share window. You can click off the checkboxes. Right at the end of the screen, it will have share sound and then optimize video clip at the end of the share screen.
Yeah, how about now?
And artificial intelligence.
Yes, we can.
My name is Vishan Chatterjee, and I will be showcasing the web app integration of the FAAIR application. The homepage provides short descriptions on the purpose of the application, the project's goals, and artificial intelligence. More media type content will be added in the next sprint of development, as well as a link to the datasets used to build and train the machine learning models. The image upload page has the main functionality of the application. A short step-by-step guide is added for users, as well as some descriptions on the problems to be solved. In order to use your application, firstly, an image must be uploaded by clicking the upload button. The batch of images can be cleared by using the X button here, and new images can be selected by clicking the upload button once again. After uploading the files, the problem can be selected from the drop-down menu here, and upon pressing the submit button, the images will be processed. Note that multiple images can be chosen, but the processing time will increase. For time constraint purposes, for this demo, I will only process one image. After the image is finished processing, a report will be generated below. The report shows a view of the original image as well as the resulting processed image, and depending on which problem is chosen, different calculations can be viewed. Here below, we can see the original image as well as the processed image. Furthermore, these are the calculations done by the machine learning model. If a user wants to save these calculations, they can click the screenshot button, which will prompt an image to be downloaded, showing these calculations. The About Us page shows a short description on the TTLAB team, as well as our sponsors and other affiliate organizations. Thank you for your attention and your time.
And then we also produced a mobile application. So we'll take a look at the mobile application also.
Hi everyone.
This was done
Welcome to
by
the mobile
Rogansi Fontalara and myself. Yeah.
lab demo. I'm Rogansi and I'll be walking us through the demo today. Okay, so first let's open the GrowSmart app. Right, so on the welcome page, we can see the current capabilities of the pilot app. Currently, the app can do feature detection for pak choy and peppers. So yeah, that's what we're looking at today. So let's get started. From the home screen, we can begin analysis and open up the menu which shows all the features which can be detected for each of the crops. We have weed coverage, damaged crop coverage, water stress area, and also development stages. Water stress is currently still in development, so today we'll just be looking at weed detection, damaged crop coverage, and development stages. Let's begin with weed coverage. From this section, we can open up the gallery, click in the button, and navigate to a picture we'd like to do, some weed detection on. So, clicking these arrows, we could preview the image, and let's try and let's see how the model deals with detecting how much weeds are in this picture. As you can see, there's clearly a bunch of weeds. So let's go back and see. After selecting it, automatically the model does its prediction, and as the model agrees, it's high weed coverage. Let's try one with some minimal. Let's look for one with minimal. So let's take one of these patches at the bottom here. Let's see. This one looks to have little to no weeds. So let's try this one. Okay. And as we can see, the model also detects that this picture contains minimal weeds. This is just the first steps to something more widely applicable to farmers. Like, let's say we get video or multiple images of each section of a farm. Let's say we take all those images and put them on a grid. So each square on the grid would be an image, and using this technology, we'd be able to detect weed coverage over a wider area, and we'd show a nice little visual showing like one square weeds, other square no weeds, and using that farmers could detect where to go and deal with weeds.
Currently, right now in the Caribbean, they use weedicides on a large scale. They don't have specific areas that they apply weedicides to. They would apply weedicide to all, like a whole field. And this is really just to prevent that application, to make it more, localized to a specific area.
Okay, so let's try one more. Let's try one more for the peppers. Okay, so let's look at this peppers here. As you can see, the model also predicts that there's moderate weeds. So we can see the little peppers, and you can see the weeds in between. So the model is working as intended. Okay, so let's head out of this section for now, and let's try something else. Okay, let's try development stages. So similar layout, so we could be comfortable with it. Let's go and try to detect development stage for pak choy, right? So let's look for some pak choy. If we open that same image, we're looking for the minimum. In this image, we can clearly see that the pak choy is in seedling stage. So let's see how the model performs. Let's go out and select it. As we can see, the the AI technology is able to detect that in this image, the plants are currently in the seeding stage. Let's try another one. Let's try these that look like they got a lot bigger, few weeks of growth. So, this is approaching maturity. That's what that's one of the labels we have. So let's see if the model could do that. As we can see, the model is able to predict that it is approaching maturity, so it's getting a little bigger, and yeah, it's able to communicate that to us. So finally, let's try crops that are totally finished growing, and it's time to collect, time to harvest. Okay, so let's open that one up by clicking on it, and as we can see, the AI technology is able to identify that these crops are ready to harvest. So let's talk about the next steps for this section, or the next steps for this kind of technology. As we can see, we have a take picture option below here. So this would be able to capture the same images and do the prediction. So let's see, let's have a little thought experiment. Let's say that you have cameras set up all over your farm, and using these cameras, you might already have it there for surveillance, but using these cameras, we could monitor the crops all over the field, and have a kind of system monitoring the stage of development. This would be more of like a automated farming situation. So like if you have like different watering mechanisms and stuff like that, where you don't have to come and monitor the crops as much, you would be able to get this data relayed to you. Okay, so yeah, that's that technology. So pretty cool stuff. Let's head out and we'll try the last one, which is damage crop coverage. This one is a little different in the sense that this is able to get more granular data. So if we open up an image, we could clearly see that how this technology is able to identify the individual crops. So for each individual crop that it detects, it will be able to then give the quality of these crops. So for here we have simple labels such as not damaged and damaged. In this image, all of them are not damaged. So let's go to one that has damage. Alright, so as you can see, we have the fuller ones in the back that are not damaged, but clearly there's little ones that clearly got overwatered, or something clearly happened to them. Some of them there's a little shrinking on the other one in front towards the middle, and yeah, they're identified as damaged. This is just one more image showing the not damaged, a nice full patch in the middle, and on the left it has one that has like some kind of shrinking going on in the middle, so that one is clearly damaged. So this is the performance of this type of technology that is able to identify these kind of features and communicate that. So the next steps for this one would be something along the lines of, let's say you take a video. All this data was collected mostly with drones. So let's say we take some video, and apps such as this one snips up, take little snapshots of each area of the farm, similar to the other example, and we're able to detect the amount of damage and not damage. This would be able to give you information on crop yield and information such as that. So
one of the applications for this is we would like to potentially in the future create a integration between a drone and this model to be able to predict losses that occur, so that farmers can get some sort of payout towards dealing with natural disasters And because of climate change, we've been experiencing more erratic weather. So it is that is a potential application of this that we hope to implement sometime in the future.
That's the last one, and sadly we still in development.
Yeah, we're still in development for the water stress identification. There's severe limitations on the processing power of a phone. So that is why we built both a phone application and a web application overall. And so now I'd like to talk about a little bit of the future opportunities. This is a pilot project. It is a pilot project, once again, led by the Cropper Foundation and TTLAB. So we did it for a couple crops. In the future, with the respective interests, we would hope to expand it to other crops. So we recently did some webinars to get the information or provide feedback to the farmers that participated in the project to show them what we can do. A lot of these farmers have camera systems set up on their farms for things like petty larceny, and they have water irrigation systems, and someone has to go to the farm and look at the crops and determine where to irrigate and where not to irrigate. And we were making a way to do that without someone actually having to go on the farm. They can just have interactions with their phone and be able to derive the same kind of information as actually having to be present on the farm. AI and computer vision together, I believe, have, created some formidable solution when it comes to detection. This coupled with an alert system can potentially alert farmers to drastic changes that can happen in their crops through pest attack or nutrient deficiencies, or simply a person entering their farm. Post-disaster, the number of crops damaged can be identified using aerial images, and this will allow for potential estimation of losses for the farmer. Losses due to pest and disease can be circumvented with early detection. But I think that the real power for AI in the Caribbean, and keeping the FAIR project in mind, is that it allowed farmers now to interact with this emerging technology and to think about custom solutions that they would want to create themselves. My parents, they dabble a little bit in the small farming area. They have a couple places where they plant different types of crops, and they are always out and about, having to go and visit each area and do things. And for me personally, this was my way of trying to bridge that and create a different way of doing things. Overall, the project really did help me personally gain some insight into what can be done with AI. And I'm now exploring different areas of research with it. But it can also, create insights into small farmers in terms of their crops, water stress, damage done by natural disasters, and other environmental issues that may surround that space of technology and that space of information. And by generating this level of landscape data, which is UAV level of landscape data, you can reduce the reliance on post-processing expertise. So my parents are now getting into it, into small farming. So their knowledge is limited to, a novice area. And I believe apps like these can help people to, automate and make things reach the level of knowledge that they need to reach faster to be able to have insights into their crops and produce more efficiently. So yeah, these are some publications that we have out. It was done through ECOSA, and we also have some done through UE for their agriculture conference, the 100-year agriculture conference. So you could visit those two links. And we also have a data set. Our data set was open source. So we were able to, post that up as part of TTLABs, and is accessible to everyone. Do you all have any questions, comments, concerns?
Well, that was a really excellent presentation, Mindy. I mean, I learned so much from what you all do. I was very impressed. Anybody has any questions? I'm opening up the floor now, so you can ask Mindy any questions about the project or any other projects that she has in the works. I think Gayatri made a comment. I am actually involved in the pre-approval of these operations from CAA. It's cool to see how it turned out. Gayatri, you want to just jump in and give us a little bit of context about that?
Hi, is everyone hearing me clearly?
Yes, we are.
Yeah, so I work at the CAA, and one of the
what's the CAA by chance?
The Civil Aviation Authority, and one of the operations regarding this project would usually come to my desk for approval. So it's good to see how it turned out.
Yeah, I remember having the we had to do training with you, right?
Yeah.
Yeah.
Look at how everybody's integrated. And I see Mary A in the chat says, my family, she has a family of farmers in Ghana. Wow, that's really nice. And she found it was a very great and insightful presentation, Mindy. I second that, and I think most of us would probably agree that it really gave a lot of insight. In terms of the crops, so how was, I don't know if I missed it when you said it, but the time span for from the start to finish in terms of this project, what was the turnover time for you all?
Oh, so the project was supposed to be 1 year. So it started in September 2020, I believe, right? And then we went into September 2021, and then we went into September 2022, and they granted us I think a 6-month extension. So it finished at the beginning of this year, March, I believe it'll finish. And what happened was we didn't know that we would get the extension. So most of the data was taken up between attaining the drone, which was, I think we got that in December, and the 6 months after that. So.
Oh, right. Yes.
And then
it's so many moving parts.
Yeah. Data labeling was very time consuming. We used MATLAB for that. So,
right.
Yeah.
How long that took on average? Did you like
data labeling took about 4 of the months after getting the data. Yeah. Because it was pixel label data. So they sit down and they are individually labeling each plant, and yeah.
Yeah, because when I was watching the snapshots, I wondered, okay, so how did they do this to map these things so carefully to the accuracy? So me, that is very extensive but time consuming, very rewarding though, because I like how it turned out. I mean, you all started with those 2 crops, so you all extending it. Is there any extension of the project now with respect to others?
There has been interest from certain large-scale farmers to extend the project to their like cocoa farming. And I know certain people have expressed interest in getting the information on how we did it and getting like the resources that we use through the Cropper Foundation. So they manage people's interests now into it, and they will come back to us and tell us, okay, so we wonder if we could get more information about this or that, and we would just supply them with the information and the technical part of it.
Oh, interesting. Anybody else wants to give any comments to Mindy? Any questions you all want to ask her? I also dropped the TTLAB and the Cropper Foundation links for you all to look at to see if anything interests you in any of those organizations. Also, Mindy, the National Geographic, this was a grant from, was this the grant for the National Geographic or was this?
Yeah.
Yeah?
Yeah, we got the grant through the Innovation for AI. So Prof is the National Geographic Explorer. And I do believe we got additional stuff from NVIDIA with respect to like GPU processing, because this image data we were dealing with, and image data it consumes a lot of resources internally to process.
Right.
Yeah.
Yes. Because Mary A, well, she had a similar question about if the project is going to expand to other crops and maybe internationally too.
Yeah, yeah, we doing it regionally. You'd have to reach out to the Cropper Foundation for that, but regionally, definitely it is expanding. So yeah, there's always stuff open for the future. Anybody wants to know about how to do it or to do it themselves, we're always here to provide the insight.
That's really great. I mean, very, very impressive. And I mean, you touched on a personal note with respect to your parents and the farming aspect. So how do they feel about this work and how it's like helping them?
So my dad is slowly trying to automate things on his farm. So we were looking to put up some cameras, but the limitation with that is that data coverage around Trinidad, especially the area that we're in, is poor.
Yeah.
And there's no Wi-Fi connection. So that's why we really had to go with a web application and also a mobile application. So you find both of them are very limited in certain ways. But it's mostly because what works for some people wouldn't work for everybody. And we were really trying to get the expanse of, everybody being able to integrate with it or use it in some way.
Right. Yeah, I agree. And I mean, of course, as you said, regionally, I think Anthony has a question for you. Anthony, you want to turn on your mic or let us know in the chat? Yeah, go ahead.
Can you hear me?
Yes, we can.
Question, Mindy. So would there be like capability to troubleshoot further problems in the soil? So in the example you give, let's say you're detecting possible moisture. Was it water levels, moisture levels in the soil? Have the capability to like make regenerative recommendations such as like mulch or anything to do with the life of the soil. So kind of deals with troubleshooting what's going on with the problems. Like as I could see in the color, the state of the leaves of the plants and things. So just like, would it be able to provide a wide range of recommendations without like having to do a soil test or any kind of specific thing like that?
All right. So I actually read a paper on that, like when I was doing this project. So there is a way using image data of the soil to determine what it is rich in. But so the data, the background data that you would have to have for that is a soil analysis on the topsoil. And then they kind of made a relationship between the color of the soil and whatever texture that they can get using contrast filters to then make a prediction on what it is rich in. And then it was able to make suggestions on what should be added to it. So yeah, there are like our project didn't specifically address that. It just addressed water stress in plants because sometimes our plants become flooded really quickly during the wet season. And when it becomes flooded, like if you have an automated watering system, you would be adding to the issue in that situation. Or if you like not everybody has the level of knowledge to know in Trinidad, like not everyone would know, all right, take off your irrigation system, take off these systems, because we don't know what the weather would look like tomorrow. So our project dealt with that part of it, but I read papers on being able to give predictions for the what a soil type is rich in and what could be added to it. And they usually use clay type soils. So it really depends on where you are in Trinidad, because the soil map of Trinidad is very diverse. I mean, we have mud volcanoes, we have in Tobago, we have coral reefs they all contribute to the soil being rich in different types of things depending on the area. So yeah, it can be done with machine learning and computer vision and these kinds of technologies, if that's something you're interested in.
Okay, would it be possible for you to send the links to these
papers?
Yeah, these papers.
Sure. You wanna drop my email address and you could send me an email and I'll see if I could find it for you.
Yeah, thank you very much.
Yeah.
And even in that context, as you said, Mindy, like what I was coming to mind besides the irrigation, I mean, in terms of the turnover of plants, because I know, well, you would know from your parents, you'll have to have certain plants grown in the soil at certain times because some of them deplete. So like you all would also want to incorporate something like that to kind of tell, well, which plant might be more viable to plant this season because of what, you know, what elements, what minerals present in the soil.
Yeah. I
I'm
mean,
no farmer, but I'm thinking that's probably what it might be.
I read some papers recently on the depletion of nutrients in the soil and that how it is affecting produce really negatively. So you have the plant, but the micronutrients that usually would be in the plant isn't there anymore. But I have some research to do on that myself. Yeah.
Yeah, it's a lot of context now because the weather's changing much. All the Saharan dust, I don't know how that would affect as well in terms of the plants. So it's really I mean the area is so expansive and we have such a unique situation in the Caribbean with respect to our weather and all the weather patterns and how they affect the soil. So it's really, really interesting. Anyone else? I mean, this is a really interesting discussion. I'm very I find it very insightful and I learned a lot, I must say. Anybody else has any comments, any questions, anything? Going once, going twice. So Mindy, any last I would say insights or anything you want to share with them moving forward, not only in this work, but in your work in general, that you'd want to kind of let our audience know?
So what I can share with you is I think the thing that I learned the hard way, like we say in Trinidad, I learned this the hard way. Anything that can go wrong will go wrong in your project. It is up to you to be able to problem solve and troubleshoot on the spot. So when things didn't work, it really, you had to sit down and research. You had to sit down and think about a different way to get the same product out that you want to get from what you set out to do, right? And I think that was the most challenging part of it because we had limited data. We had, constraints placed on us being able to actually go out and get the data because of COVID. And I think we went into lockdown. We got the drone and went into lockdown like right after. And it was just like, okay, cool. It was just, yeah.
There's a lot happening at once.
Yeah, it was a lot happening at once.
Yeah, you have to like look into the project management risks then.
Yeah.
Account for the risks that would happen. Mary A has another interesting question. She said, I know you are focused on crops, but is there other data included like water and satellite data regarding weather patterns and how it impacts the crops?
So there is satellite data. I believe it is Sentinel-2.
Right.
And there are different sensors on Sentinel-2. That means that you could get different filter data. So in TTLABs, there were recently some papers on NTVI and predicting using Sentinel data or satellite data to predict the amount of biological material on the surface for a specific area. And they had access to some LiDAR data too that allowed them to be able to tell distances and determine how much trees that there were in a specific area. I don't know specifically how much what detail it goes into, but if you visit the TTLABs, it's under publications, one of the publications that they recently did. And there are a couple of people that use satellite data like solely because going out and getting UAV data is challenging. So they tend to do a lot of their projects around weather and satellite data and carbon sequestering. Yeah.
Wow, you're learning lots of new terms here.
Yeah.
And she also extended some congratulations to you and the team. And I agree, it looks like a very, very it's an amazing project and it's meaningful. I like when it's meaningful to the person who did it too. You know, especially in the context of your family background as well. I like that. Anyone else? We have a few minutes again. Ariane said that it was very insightful. I had no idea data could have such an impact on agricultural processes. I agree. Yeah.
It is way better. They have drones that do many different things that like 3-dimensional photometry that allows you to get, you know, I watched this video recently where they use an AI, they taken the images about this high from the ground, and they're able to identify the specific plant and what the specific plant needs and spray it like as the thing passes. It was interesting.
That's interesting. Yeah. Well, look at that. I mean, the digital revolution is going so fast. So you know, it's going by really, really fast. Yeah, so we'll try to keep up. But anybody last words before we sign off for today? I think Mindy, on behalf of the group, on the team, we would really like to really thank you for this insightful conversation and the spotlight talk today. I think everybody has learned so much, and I think it's very exciting for all of us to see how you were able to use your background in this way to apply to agriculture. So I really want to see you all do for more crops and come back and do some more, you know, some other fancy things like how you have been doing already. So looking forward to that. And if you all want to reach out, yeah, go ahead, Mindy.
No, I'm in the mood for some fishes now.
Oh, you want to switch?
Yeah, I look at some crops. I want to look at some fishes now.
Fish, yeah. Sure, sounds good. So anybody wants to reach out to Mindy, you can email her, go on our website, and you can find her on LinkedIn as well. And I'd like to thank all of you for joining us today. It was really a great conversation, and feel free to join us for the next one. And we have a feedback form for you to sign up in the chat. So please fill out our feedback form, and we do look forward to having you join us. Mindy will also be on our panel next Saturday for the Fireside Chat, along with some of our international data scientists. So we would look forward to you all joining us for that event as well. Right? So do enjoy the rest of your day, night, evening, wherever you are. And thank you again, and we will see you all in the next one. Take care, everyone.